Spinetta, an MIT freshman here to talk to you all about eggs. Eggs are a fridge staple and an ingredient found in all sorts of snacks, meals, and desserts. While they're so common, have you ever thought about what you actually know about the chemical structure of eggs? Whether you'd consider yourself an expert or you've never really thought about an egg outside of a bacon, egg, and cheese sandwich, we're confident that if you follow along in this series, you will learn some fascinating and useful information to up your kitchen game. Before we get into all the great things about eggs, however, we wanted to start by addressing the dietary taboo of eggs, specifically the egg yolk, and the bad rep that it garners in the nutritional world. That's why today's videos will focus on what you need to know all about cholesterol.
So, to begin, we're going to introduce you to the biochemistry of cholesterol. Cholesterol is a 27-carbon compound with 4 rings of carbon, a hydrocarbon tail, and a hydroxyl group attached to the other end. Cholesterol is a special type of lipid or fat called a steroid, which is defined as any class of natural or synthetic organic compounds characterized by a molecular structure of 17 carbon atoms arranged in 4 rings, which was what we saw in the molecular structure before. All steroids are lipid-soluble and therefore not water-soluble. Cholesterol is extremely nonpolar, except for the hydroxyl group, the OH, at the end. This means that in a cell membrane, which is drawn here in this picture, the polar hydroxyl group will stick to this water, which is the blue on the outside, while the rest of the nonpolar cholesterol molecule is among the nonpolar fatty acid tails of the phospholipids. So in this drawing here, the red circles represent the polar head groups of the phospholipids, and the zigzag lines coming out of them are the non-polar fatty acid tails. And this drawing shows a bilayer of phospholipids. Cholesterol is the foundation of other steroids, glucocorticoids, mineralocorticoids, and sex hormones. All of these molecules play important roles in the body's endocrine system, which controls all the hormones in your body. Cholesterol's other important function is in animals' cell membranes, as drawn here. Due to cholesterol's rigid structure, cholesterol plays a crucial role in maintaining the right level of rigidity and fluidity in the cell membrane. Cholesterol's hexagonal ring structure makes it inflexible and more bulky. Thus, in the cell membrane, compared to the phospholipids, cholesterol maintains structure and position more firmly. This structure and function of cholesterol is crucial for the cell membrane in unideal temperature conditions. For example, heat would cause the cell membrane's components to move too fast, creating gaps in the membrane for unwanted particles to enter. Cholesterol makes it difficult for components of the membrane to move around too much, preventing it from being too fluid and flexible to the point that it can't hold shape. On the other hand, too cold temperatures would cause particles to pack too tightly to let important particles in, which is an issue because the cell membrane is essential for the transport and filtration of materials in and out of the cell. Cholesterol prevents the membrane from becoming too rigid and also losing flexibility. Ultimately, without cholesterol in animal cell membranes, cells would be subjected to unwanted particles or lack necessary molecules for cell function. So now you're probably wondering why cholesterol gets such a bad reputation. Well, your body only needs so much cholesterol for cell function, and your liver makes enough cholesterol to not require any dietary cholesterol. But dietary cholesterol still exists in most animal products, including meat, dairy, and of course, the reason why we're here, egg yolks. Excess blood cholesterol can cause health issues, particularly cardiovascular issues. Before we dive further into it though, let's define some important terms. You consume dietary cholesterol in the form of HDL, LDL, and VLDL. HDL stands for high-density lipoprotein and is considered the good cholesterol. LDL stands for low-density lipoprotein, and VLDL stands for very low-density lipoprotein. LDL and VLDL are considered the bad cholesterol. For the most part, LDL and VLDL share similar properties and roles in the body. So in this video, we will just focus on HDL and LDL. HDL has a higher ratio of protein to lipid than LDL. In contrast, the LDL molecules have a higher ratio of lipid to protein compared to HDL, and they deposit fatty acids that build up on the arterial walls. The cells of the arterial walls secrete oxidants that break down the fatty acids into plaque, which will be shown in the drawing here. The buildup of arterial plaque is known as a disease called atherosclerosis. Atherosclerosis can lead to inflammation and a narrowing of the arterial walls. As a result, atherosclerosis is a main factor in coronary heart disease, which can lead to heart attack, stroke, and death. While increased levels of LDL are dangerous to the body, increased levels of HDL actually benefit the body. This is because HDL transports cholesterol out of the tissues and blood to the liver, and then in the liver, cholesterol is broken down into bile salts, which can be excreted from the body as a waste product. By decreasing the concentration of cholesterol from the blood and tissues, the high concentration of HDL thus decreases the amount of LDL oxidation that can occur.
So to conclude, HDL and LDL are the forms of dietary cholesterol that humans obtain from consuming certain animal products. Eggs are a tricky case, though. The egg yolks have both LDL and HDL, but they also have high levels of protein, which are important for cardiovascular health. So the topic of debate, and many studies to this day remains, are eggs, and specifically egg yolks, bad for you? Unfortunately, the answer remains widely disputed. A study published in 2019 found that there is a significant association between a higher consumption of cholesterol and cardiovascular disease and all-cause mortality. A more recent study, however, published in May of 2020, concluded that there was not a significant association between egg consumption and mortality rates. Today, nutrition guidelines suggest limiting consumption of dietary cholesterol to 300 milligrams per day. However, one egg has 186 milligrams of cholesterol, over half the recommended limit, and indeed, all of the cholesterol comes from the egg yolk. So while we don't have any definitive answers about the nutrition of eggs, we do have some fascinating information to share about their biochemical properties. They make these so versatile in a myriad of recipes.